Okay, hello. Thanks for joining in. Hopefully someone does. Just check. So we're doing a live stream, a detection, chart detection with Python. And now instead of ChatGPT, we'll be using GitHub Copilot. The data is from a Kaggle competition. The link would be in the descriptions somewhere. Just checking my own stream and sound. Working okay. Know which phone is my headphones. Bluetooth headphones are getting busted. Well, one of them still works. I'm pretty sure it was the left one. Now it's the right one. But that's okay. Want to check a thing in a YouTube itself because we haven't done this before. Assuming it was like too heavy. I do want to monitor my GPU and Wi-Fi usage. It's sending about 17 megabits per second. Put it over here for a sec. Just check the sound again. On another device here, I had some issues with sound before, so we made a spelling mistake. And we need the Zoom link as well. Pop it in the chat just in case someone wants to join in live. Just check, say this to 15, right? Jumping to double. This tool is a bit heavy, as you can tell. Get out of we in another window. Right, that's actually pretty good. It stops streaming. If we place it 84, this will continue streaming. Yeah, it's only actually when you view it, it streams the 30, which is pretty good. Really checking my internet connection. I should, yeah, I I think I have 40 upload is the maximum upload that I can have. If I have a fourth one, we'll start struggling. And now probably my live stream will start dropping frames. Well, not yet. Just open one more. Not dropping frames, which is good. So yeah, I'm essentially getting 50 megabit per second is my maximum a download speed. And let me just in another window here. Have like 8K or something, 4K, 8K video playing. We got received 56. Is it 4K? Quality auto. No, it's not 4K. Now it's 4K. Right, so we're reaching 130 and up to 50 download. That's pretty good. And yeah, and it's YouTube 8K, so it's actually loading stuff and then it will be going down. Uh, and the stream still not dropping any frames, which is good, pretty good. Let's stop that video. Just checking the internet connection essentially. And yeah, and as we close those, we should also reduce this 50 maxing out. Still 50, 40. And they're pretty heavy, but they still work. They work independently, so that's good. Yeah, so that will be about 15 megabits per second each. And that's turning them all off. That's the 15 megabit per second, which is the live stream. This is the last tool on bunnychaos.com which we published a while back, like a week or so ago, and it's a Plotly JavaScript. This is running on Bunny Chaos server. Seemed to work just fine. It's an actual digital interactive image. It's scalable, which is good. Oh, actually select things. Do that. I don't know why, but to be an over engineered thingy. But okay, that's for data selection. So I guess yeah, if you have a scatter plot, you can select the it doesn't get rid of it. You can restart the page to get rid of it. What else can you do? So this is relevant to the current competition because what it does is take an image, because normally, surprisingly, in publications and PDFs or even HTML, um, charts and graphs will be published as an image, and they would not be interactive, which is a bit of a problem in general, especially for people with like reduced vision and the like. So we want all graphs to be like this. So this is just an example on bunnychaos.com. And on that note, we are doing this Kaggle competition, which is relevant, which is taking images of charts. Go over it again. There's a video published yesterday, just to summarize what the competition is all about. There will be more of those coming soon. Find it. Kaggle. It's a competition sponsored by someone. Benetech, something. That's what it's called. There's already almost 600 teams involved. That's the description of it. Yeah, I don't know. I haven't read the requirements and everything because yeah, we're just using the data set. So it's images like this. They're not interactive. And you're meant to return. So there's 60,000 something labeled. So you get the type of the chart and the data from it. So you have vertical bar, horizontal bars. You have now vertical bars, it's just examples. True. Is numerical. There's some Python example there. So we already have a code running. Let's see what we did so far. I think there's 5 different types. Yeah, and scatter plots. So you can start with scatter plots because just find any data points in the image. But yes, we need to find the title, the y-axis, the x-axis, mainly the tick point numbers or words. There could be non-linear data, like like over here. But yeah, we might leave those ones for now. The dot plots, a bit weird. Might leave them for later. So let's see, what have we done so far. So this is all the good code that we have. And we're trying to make a model in TensorFlow at the moment. But so far, oops, so far, oh come on, this scroller works. Let's just check. Right, so we started off this. This will show the original image, and obviously it does what it does, some circle detection. That obviously doesn't work well, so we can get rid of this one. But yeah, this scroll shows there's 60,000 images. Most of them are synthetically generated. Some are actually extracted from open source publications. So it's also in the labeled data. But it's kind of not very important for this. For this one, we can close. I forgot what this one does. It doesn't do anything, it's just broken. It just has this scroller. So I can get rid of that. Oops. Yeah, this is the previous code that we did in the last week. This one returns an error or something, doesn't it? This one doesn't do much. That's a rack, yeah, that's okay. Right, this is just oh right, this is extracting the text in the image using the OCR tesseract thingy. That seemed to work. That's the text there, but we actually have a better version of that actually plots the image. The output is truncated. Why? Yeah, we can close this one. This one again using the tesseract and pillow, but it's actually not producing anything. So we can close this one as well. This one is labeled great, so it must be doing something useful. It's importing the libraries. Right, so this one, so this label is taken from the ground truth. Doesn't look like, wait a second, not, right, this one does line detection on the image. So I don't know why those things are detected as lines. So it's the wrong. We wanted to then filter the lines just to a horizontal and vertical, just to start off by finding the x and y axis, because we need to do that to essentially split the image into different regions. So we're looking for data set within the axis and all the labels text outside the vertical and horizontal L shape lines. So might keep this one there. It's a good code. Forget what this one does. Right, so this one does the same thing, but also the text lines, but also detects text in the image and just overlays the text. Sometimes it's working okay, sometimes not so much. So interested why it changes the color of the image, because it's transferring it into grayscale and then obviously doing something with it. So in this case, it found country 2005. That's okay. 0 is, and I don't know. Sometimes it's making those mistakes. So it's finding, yeah, this stuff which is obviously nowhere to be found. And there's more text that doesn't fit this image, so we have to correct for that. Yeah, so it's doing something in the colors, that last one, the text detector. Yeah, so we need to find this L shape, and we will be looking for text outside the L shape, and looking for data points inside it. And inside the L shape, or where the data point is, if it's finding lines, it's more likely to be a line plot. In this case, I wouldn't know like why. Yes, scatter. So say plotly actually doesn't have a line plot. It will have a line plot will essentially be scatter plot with lines connected between the data points, and then you can select if the actual data point indicators are visible or not. So like here, this could be a line plot as well. Right. So we'll keep these two. And what do we have there? Oh, get this really scroller to work properly. Right, so I don't like this one. The text is too large. I think there was an attempt to actually place the text where it belongs on the image, but obviously it's not very great. Yeah, here it's messing up the words. It's doing like V instead of X, and C instead of R. Yeah, it's really bad. So I don't know what's up with that. We might close this one as well. Have an image scroller. Right, this is actually meant to show 4 images, but for some reason it doesn't work. It only shows 2. So I might get rid of it as well. Not very helpful. What's this one's doing? Ah, right, because it's one function, not separated into. Right, 2 by 2 images, bunch of functions. Run this per sec, see if it actually works. It's meant to be 2 by 2, but it's actually the same 3 images as we had before. We might get Get rid of it as well. Get a 2x2 scroller. Give us 2x2. Right, this one works. It's 2x2. The last two are just the same. That's okay. We had another one where we will display the ground truth from the JSON file on the side here. We had the scrolling. Scrolling the JSON files. I remember that didn't work well. Well, that's just the JSON file, so that's what we have in the file. This one says if the source is generated or retracted from an actual image, and then the chart type, and you have dots, lines. Right, this one is actually extracted, and all the ground truth. So ideally, we will generate a JSON file like this. So yeah, it's a kind of funny JSON file, but okay. So we just made this scroller for it. That seemed to work okay, but yeah, nothing special. It's the 2x2 with JSON file. That where is the JSON file? Yeah, I remember having trouble with it. JSON file would be in this fourth image. So you have line detector, text detector, and the JSON file, but obviously, yeah, there is a problem with how, like, it's not great because there's no scroller to the JSON file, so you can only see one section of it, like in a random section. It's not in the beginning or something. So I don't know what's up with that. We can probably get rid of it as well. Let's check out the next one quickly. So that's what we did in the past week. Right, so this one is handy. Again, will be the original image, line detection, text detection, empty image for, next stage. And then you have the JSON file in there, but again, there's no scroll to this. That might be not that useful. We'll close that as well. Generate a lot of stuff. This one has some problem in it. Doesn't have a minimum line length. So this one, detecting lines, yeah, it needs a minimum line length. I was actually asking it to make the minimum line length so it's at least a quarter of the image size. Obviously this one didn't do it, so we can get rid of it. Just one sec, I'll come back in a sec. Hopefully someone joins in as well. Yes, sorry for that. We'll have to obviously for those live streams will eventually turn into shorter videos, hopefully nice and concise. Yeah, it just takes forever to edit videos. So yeah, if you have any tips on how to do it quickly, all ear. Let's see. This one also has a few issues. There's no image size function, even though this one has an image size function. Do we have a we have Copilot running. This will be something running. No. Anyway, let's move on. And by the way, this one has a text to speech. Right. Yeah, it's not a great text to speech, and it's also not going into the stream. The best text to speech so far that I am using, and I'm pretty much tried them all, is the one in Edge Microsoft browser. It's a really good one. Okay, so we need the image size and all sorts of other things. So let's move on for a sec. Okay, so this one is a plotly data. Yeah, loading the JSON file. Again, we have some see what it does. It gives me an error. But the NB format, what? Mime? Don't remember using mime. Wait, this is the wrong. I know it is JSON to graph. What JSON? Anyway, we can move. Right, so we have this two folder, training folders. Anything useful? Exception. What? Why is it not able? First, this is wrong. This is something ChatGPT generated for us. Keeps going. So this package needs Python 3.6.8 or something, or what? So that's odd. seems to work okay. Two is just stuck. And this is something we generated with ChatGPT without the keyboard interrupt. That's okay. Right, so this is what we did yesterday. We looked at this the TensorFlow example and seemed to work okay. Running this, it's downloading a data set of this images of flowers. You probably used this example before. It then splits. There's a 80-20 split. Just using this one function essentially to do quite a bit. Can we use plain batch? There's no. It is to do how to use Copilot properly yet. It's possible this could be just an explained thing that right, so it's cares API, public cares utilities, labels, don't need labels. Right, so selecting a directory. Yeah, there's no real explanation. Ah, no, there is. So it generates a data set. If your drum frame, right. So the directory needs to be in a certain structure. So you have to have, right. So for this to work, you need the files in different folders. Okay, do we? So currently we have all the image files in one folder. Where was it? Then calling image directory will return TF dataset that yields batch of images from the subdirectories class A, class B, together with labels 0 and 1. Supported image format, yep. We have JPEG. Not this JPEG though, it's just JPG. Hopefully it's okay. Well, it should be the same. Then arguments directory where the data is located, class. If labels is inferred, it should contain subdirectories each containing images for the class. Otherwise, the directory structure is ignored. Okay. So what are the other options for without data set? We should, so our annotations are in a JSON file, and we do have it as a variable. It is variable generated from directory. Labels are generated from directory structure, no labels, or list, yeah, of integer labels. Right, so those are not integer labels. Labels should be sorted according to an alphanumeric order of the image file path obtained. Okay. Label mod string describing the encoding of labels. So yeah, I need this a there is a string describing the chart type. So let's see here. So this is what we had, the last thing we had. Yes, it's a Python generated model that recognizes, predicts graphs or charts. Training data. Yep, so we potentially need all this stuff. Let's run this quickly. It's running. Model training. Oh, come on. So those are folders. We have the training images, we have the annotations, but this is in JSON format. Wait, yeah, test image. We have test images, and we don't have this folder, so assuming we'll need some prediction folder. So we don't have this folder yet. Yep, will be created by the model, or maybe then is it running or what? Right, so importing required libraries. So by taking some time, but seem to work. There's a warning. Hopefully those are folders. Right, those are the number of images, and yeah, annotations should be the same number because there is a corresponding annotation to each image with the same name, just JSON file, and the images are JPEG. So for whatever other reason, we do have a GPU, but I guess because so this is calling a TF is a TensorFlow, and it's the TensorFlow needs to be reinstalled with a GPU version, and I had trouble doing that. So I don't know what's up. Can you use use GPU version? Right. PI docs. Okay. Do I need to set memory, set visible devices, least physical dedicated? Right. Anyway, get it. So I have to do all this. Experimental, get virtual. Okay, is there any more? Okay, that's probably enough. Might just get rid of it for now. We have to do it later. So because we are not loading onto a GPU, we're just loading 100 images. So we have a limit. Where's the limit? A limit. A limit. Right. So we have a limit. Where's the Jupyter? Right. So we have 100 limit is already there. That's just to make it run quicker, faster. And this will create train a load 100 images. So that's worked okay. And then the problem that we had last time, so it will generate right. So we right. So this is a numpy array. Where is it? Data diction. It's a dictionary. Data. Don't like the data bit. What's the data? That's the annotation folder. So that's the JSON file stored in a dictionary and has all this stuff in it. Source chat type. Yeah, so that's the train annotation list. Right. Convert the train images into numpy array. So this is where it becomes funny because so a numpy needs everything in a numpy array, which is okay. But then a TensorFlow needs everything as a tensor. So, and currently train annotation list is just, wait, right, it's just a list with annotations, and the train images list is also a list. It's a 39 by 39. What? Failed to create data viewer. Check the Jupyter tab. Why am I? Right, now it's working. And that would be loading. Oh, wait. Why is it failing to extract the variable? Oh, yeah. Okay, it's doing it forever. And it's only 100. It should be a list of size 100. The problem is, okay, bottom line is if we keep going, yeah, we need to convert it into numpy array. So it made a numpy array. So let's see if it's loading now. Yes, it does. So at least it's much quicker. So we have that, and we can print the shape. Right, it's 100, size 100, size 100. That's okay, I think. Right, then we just display one of the images just for kicks. where's the hidden. So this particular image, index 55, is a line array, and it will display the image and take the chart type from the a JSON file. So just confirming. And yes, ideally this will have a scroller that you could scroll through the files, but that's okay for now. We'll just assume, we did check a few yesterday, we just assume that the ground truth is correct. That the ground truth is truth. One sec. Give me a second. By the way, this is also available on Zoom. If you want to actually join in and have a conversation, that would be awesome. Give me a second. This Zoom window is funny. It's like it doesn't, if you minimize it, it doesn't get minimized. It stays as a small window. That's okay. Right, where were we? Right, so we plotted that one, we closed. So this one can be essentially ignored. Now, this is the funny bit, because to run a model, we need to convert essentially the data. Right. Follow that link. That link is into PyTorch. But a lot actually requires the input that the subclass dataset. You can either write your own dataset class that subclasses dataset uses, or use Tense dataset. Right, so that's using Torch, and I'm using TensorFlow. Let's try it again, and if it doesn't work, probably just try doing it with a PyTorch instead. Essentially, my data is not in the right format. This array, is the array meant to be two-dimensional, isn't it? Just a 1D array. Does it need to be a ND array? Train, just list. Well, because when I run this, I get an error, failed to convert an array. numpy array to tensor, unspotted object type numpy nd array. Spotted, what? How is that unspotted? I'm not actually using it. No, that's only one suggestion. Nothing else. Get to tensor. Convert to tensor, convert skin value to a tensor. This function converts Python object various types to tensor object, accepts tensor objects numpy arrays, which what this is, and Python scalars. Goes. So we have a base model. Oops. Weights, shape. That's the image shape. Bottleneck features had drastically lower parameter count than original mobile. Image, larger image size offering better performance. Okay. Function returns scarce image classification model option loaded with weights pre-trained on ImageNet. Okay, so the ImageNet should tell us what type of what's in the image. It's a common thing to do. Then we create a function to build a model. We use base, add the base model, sequential linear stack of layers into sequential provides training and inference features on this model. What model? Tense. We're doing tense 5. But the model units activation dot input kernel. It's kernel's weight matrix bias. Session. Build model, create a function to train the model. Right. So this bit will be giving me error because the input should be a tensor. Should be. If this doesn't work, we'll have to try PyTorch instead because I don't understand. Yeah, based on this example directory. Yeah, but I don't do I have to. Right, so I'm not loading from directory tills tensor with an IP array. Okay, how about instead of doing this, we just try loading the data a keras. Oops. Right. No. No. We want to test images folder into as tensor into keras. No, we already have a numpy array. We want the tensor. Okay, no, we don't want a link. we, we want the code. Image does it again. It's from directory, and that directory is not in the right. Inferred. I think we can have inferred. Yeah, that definitely images in that direct. What? How come there's no images? It is true. Should be train images. Train images. Right. So we uh, so this the train images list and the array. And now it's a list. We don't need to convert list of. This wasn't working anyway. To figure out how the Copilot works. Right, this one needs an image path. A turning grayscale, reduce noise. Yeah, that's very similar to what we already had. Don't know why. Is this what the what's the OpenGPT? This is an NLP model. Wait, open source GPT. Which one is better? Well, we'll continue this later. It's started giving me for some reason. It do. So supposedly GPT-2 is an open source. There's a GitHub library. Right, where were we? Go to code. This one. did run this one, did we? Yep, several times. And this image load image. I went to ask just comment all this out. Don't need to convert. Let's see if we give it. Oops. Now we don't need to convert. Initialize a model. Oh, come on. I think we might move to understand. Model. Okay, let's use the ImageNet. That's okay. That's like a problem. I don't understand. We don't need to convert. With the shape. No, nothing. Yeah, well, this is my first time using the Copilot thingy. I don't really. It's just repeating stuff that I did before. Don't know. the image we want to train a model. Here is load images from folder as stanzas. No. I already did this. Keras. OBS. That does work. What does it do? Anyway, yeah, there's obviously no magic. Keras. So we have the images. Reprocessing it as before training. It's deprecated. Oh, it didn't tell me. Okay. Keras. Rain. No, that was okay. That was correct. Keeps going for the numpy array thing. Get it. So we examined and understood the data. Need to build the input pipeline. DF data to load the images. Load data images. But the other should be just in a different format. Yeah, this page just doesn't exist. Let's just make it up. What did I say? Can I do the same but use Python collision restrict graphs and charts, training for the JPEG? Yes, plot vertical bar plot. That one is weird. JSON file. The question is, can you use okay, can you use a PyTorch instead? That's just hallucinating, isn't it? Just trying to figure out how. What? Okay, now it's just hallucinating. Instead of all this, PyTorch. And this looks familiar. Supposed to know this. I think I do. Already giving me what? It's not it. Resolve. What is it? Pylons. What exactly? I know what to do. I just wanna make sure it's not bad. CMD. That folder. Need this folder in CMD. Oh, okay. So we can run this. I was running my taxi and I need a break. Come back in a sec. Okay, so that was installed successfully. Yeah, that's the sec. Things should go. Restart. Restart. just happened? Just crash on me. It keeps going TensorFlow. It's not happening today. Not just giving me. Actually not doing anything, is it? Still not detecting GPU. I didn't get it. If I needed the links to understand why is it version of TensorFlow. Okay. Yeah, probably do need. Is it the same for PyTorch that you need this different version of it? No, it's okay. Just use the CPU. Oh, yeah, I have to take this offline and continue tomorrow.